There's a lot of things that we're going to learn by living and working on the moon. So there's some things we're going to really learn to do before we're ready to move on to Mars. But I think it'll be in our lifetimes.
The countdown to FabTech is on. FabTech is the place to be for the latest and greatest technology, industry knowledge, networking, and more. Meet your favorite influencers, see live equipment demos, and make connections to advance your career. This is North America's largest metal forming, fabricating, welding, and finishing event, and you don't want to miss it. Register for free today at fabtechexpo.com, and I'll see you in Orlando. And now, back to the episode.
Hello, welcome to today's episode of the Fabricator Podcast. We're recording this at IMTS in Chicago. My co-host for today, Lindsay Luminoso. Welcome to the show.
Thank you.
Making her debut.
Lindsay is making her debut.
Yeah.
She's also our senior editor, digital editor for Canadian Metalworking Magazine. On today's episode, we have Sharon Cobb of NASA.
She's like the third highest ranking member for the Artemis project.
Artemis program.
Yeah. She's associate program manager of NASA's Space Launch System program.
So she provided a keynote address today here at IMTS, and she joined us for a few minutes to kind of talk about her background and the effects of her job in the program to get back to the moon.
Yeah.
And I think it's a very interesting conversation. We were speaking before the recording about our experiences in terms of maybe being interested in a career in space. You had a pretty good story, Lindsay.
Yeah,
Share that.
I'm not sure it inspired me to want to go to space, but when I was growing up, our school went to like this science center program where we were each assigned like roles like within mission control, and then they had this like replica of like a rocket that you could be a part of. And you swap out halfway through the day, and partway through, our mission control was not good, and we were like plummeting to the earth. And I just thought, this isn't for me. I mean, it was controlled, but I mean,
Were they literally like audio clues, like alarms and bells
and shaking, like it moved.
It was traumatic.
It was traumatic. And to this day, I get on an airplane and I think, no.
Oh, wow.
Man. That seemed so really.
They turned
our
me
guest
off.
today. Our guest today was like talking very, very inspiring generations to join. It seems like in Canada we might be scoring some students.
Or maybe my class just was not,
ready for the
Ready
space
for it.
program.
She didn't
Yeah.
she didn't pass the first test to work for NASA.
Yeah. We all failed, but I'm sure that there are kids that probably were successful in this. It's like an escape room. Some people make it, some people don't.
Right. Well, they let you out eventually.
We were let out too, but scarred for life.
Yes.
Wow. I wish I had something to add to this, but I was kind of like, yeah, I never really thought. I didn't think about any career until I was like in college, my senior year. So
Well, I guess I'll write words.
yeah, that seemed like a decent career choice.
And now we're throwing them in front of a microphone and a camera to talk to like people from NASA.
you would think like I love science fiction, absolutely love it, watch it, read it, and just never any desire to like, yeah, I'm pretty good here on Earth. Yeah,
I
Yeah, but
agree.
she had a lot of great things to say about the Artemis program. She
Yeah.
brought some cool patches.
she did. And the I think the thing that jumps out at me, I did hold it up already. Just because you're on the internet not paying attention. Just, there's a lot of people contributing to
Oh yeah.
our effort to get this is collective, my contribution. No, the effort to get back to the moon. And I think the point that really stood out to me was this is not just kind of recreating the efforts of when they land on 69. This is an effort to get beyond the moon. And it's going to take a while, but a lot of the things that need to be proven are going to be done on the moon. To me, that was really exciting. So, more power to them. I hope they get it done. But I don't think I was ever destined to be a part of something. So. so impactful.
I mean, I liked the idea that you could be making the smallest component and maybe not even know where it goes within the grand scheme of things. And as the rocket takes off, you're like, I'm a part of that. And it's just like, that's really sup- unique and
Yeah,
surprising.
but I think you've had that, right? You run into shops that contributed
Oh
a part to
yeah.
something. I mean, it's really, I think that's kind of the exciting part of being in this industry, is that everybody's got a connection to something you might not necessarily think they would.
Right. And sometimes they don't know either, right? You just get the spec of what it is and then you think, where could this go? And it could be on a rocket somewhere in space.
Right. Yeah. So we think you'll enjoy this episode. Yeah, stay tuned and enjoy.
If you're involved in the pipe and tube industry, you won't want to miss the Pipe and Tube Conference this November in Omaha, Nebraska. This event is an excellent opportunity to connect with industry experts, stay up to date with the latest technologies, and explore new business opportunities. You'll leave the conference with a wealth of knowledge and new connections to help your business succeed. So mark your calendar for November 13th and 14th and join us in Omaha for the Pipe and Tube Conference. Register today at fmamfg.org. And now back to the episode.
Hello, welcome back to the Fabricator Podcast. Today's guest, Sharon Cobb of NASA. Thank you for joining us.
Absolutely thrilled to be here.
And also, I wanted also to reintroduce Lindsay Luminoso. She's our senior editor, digital editor with Canadian Metalworking. We're doing this at IMTS, and Lindsay's been very busy covering a lot of events and meeting with people in the industry. Welcome, Lindsay.
Thank you.
Sharon, you're big dog around here.
I don't know
Keynote
about-
address person. Can you give us a little bit of an idea of who you are and your background with NASA, and maybe what you touched upon at today's keynote?
Sure. So my name's Sharon Cobb, and I serve as the Associate Program Manager for the Space Launch System. And that is NASA's massive rocket, mega rocket that's going to send humans to the moon for the first time in 50 years. So we're building that. The program management is at the Marshall Space Flight Center in Huntsville, Alabama. So we're responsible for building that rocket, and then of course it gets integrated and integrated at the Kennedy Space Center with the Orion spacecraft. And this rocket will be the only spacecraft capable of carrying the crew and co-manifested payloads to the moon within the next couple of years.
Wow. How did you get involved with NASA?
So that's kind of a long story, but it started with my dad taking me through the plant that he worked at, a steel mill in Birmingham, Alabama. And I was absolutely fascinated by the hot metal and the pouring of that metal and shaping it into different parts and all the different things that you could do with that metal. And so I went into materials engineering, went to school at University of Alabama in Birmingham. And through that, I spent the summer on a program at NASA where interns could go do research in the labs there. And so that kind of started my career at NASA. From after I got out of school, I got a job there and worked in a research lab for many years. And then after that, had the opportunity to come work on the Space Launch System from the beginning of the program to its first flight and hopefully many flights afterwards.
Wow. Is that something like they kind of pull people into a team to work on a certain project until it fruition, and then you kind of go back to what you were doing, or do you move on to another project?
Well, it kind of depends on
There's
the
a continuation
project.
of it, yeah, right?
So for the Space Launch System, it's not just the rocket that we flew back in November of 2022. We're building another variant, in fact, two more, that'll be even more powerful and more capable of lifting even more payloads to space.
Oh,
So
wow.
we're building a new upper stage that will change out with the original one that we flew, and so that'll give us more power and lift. And then eventually we'll swap out our solid rocket boosters for ones that are made. The casings are made out of composites, and so because it's lighter weight, you can fill those with more propellant, and you can get higher pressures because of the strength of those canisters, and so we'll be able to lift even more to the moon and eventually onto Mars.
We're a metal focused kind of platform, but I'm gonna ask about the composites. Do you find it interesting? You had this interest in metallurgy, and now you're kind of dealing with these materials that who would have thought would have existed 25 or like 25, 50 years ago?
Absolutely. And so while my heart and my original interest was kind of in metallurgy, once I got into materials engineering, I realized that there were so many other possibilities and so many other things that you could do beyond just metals. And so, there's a material for everything, and the processing, that the way it has changed over the many years that
Hmm.
I've been in the business. Advanced manufacturing is making it so much faster and cheaper, and building safer, more reliable parts than we had in the past. So it's just amazing the progression that this industry has seen over the years.
Yeah.
Makes us able to do things we never thought we could do before
Right. And haven't done.
and haven't. That's
Yeah.
right.
Wow. Is there a lot of confidence going into this that, uh, I mean, going back to the moon, I mean, I don't know how many generations have like passed since we've been there.
It's been
It,
over 50 years
wow.
since
Wow.
we had humans on the moon.
Hmm.
So, in the meantime, we've been doing a lot of research in low Earth orbit on the International Space Station. It's been an incredible project in and of itself. But at this point, we're ready to take humans back and begin our exploration journey beyond what we're doing today. So, deep space exploration requires some different technology and some different equipment. We'll be building an orbiting platform that the astronauts will spend some time in. It's called the Gateway. We're also developing new spacesuits so that they can spend a little time on the surface of the moon. We're building human a human launch platform that will a human landing platform that will allow us to send the crew down to the moon. We'll have to build habitats. We'll be building rovers.
Oh, wow.
So there's a whole infrastructure that'll be required to live and work on the moon long term.
Now you attended the presentation
Yes.
today. What when people start talking about space travel, I mean, that's kind of the showcase kind of, I don't want to call it industry, but that captures people's imagination, captures people's memories. How did the crowd react when Sharon was speaking?
Well, I think everyone was mesmerized by the photos of just the sheer volume of what goes into that project. And just in terms of some of the technologies, the innovation in technologies, how does that drive the way that you design the next generation of the project that you're working on?
That's a great question. So much of what we learned in the space shuttle program, we developed a lot of techniques. Something called friction stir weld is just a workhorse for us in building these really large structures. And so we've had to develop new tools. We've had to develop new process schedules in order to use that and adapt it to the new designs. But all the new technologies that we have give us such a broader design ability to be able to really be efficient and to get the most power out of the rocket that we're building.
So you'd mentioned this is your first time like at IMTS, and this is a trade show where you have four huge halls with everything from metalworking to some fabricating, a whole area dedicated to additive manufacturing. There's quite a bit here. How's your introduction to this world been?
It's an amazing conference. I'm blown away because, my heart and soul, my original interest in materials was started in manufacturing. And one of the things I love to do as part of this program is go visit the vendors and go visit the suppliers and see the manufacturing in process. And so coming to something like this and seeing all the new innovations and all the new technologies that are available it's really exciting for our future.
Do you work with additive on a regular basis?
Oh,
How
additive
important is that?
has been a game changer for us. We when we started this program, we had 16 Heritage Space Shuttle RS-25 main engines, and so for the first 4 flights of the SLS rocket, we'll be using those engines.
No kidding. Wow.
But now that we've got them all completed and adapted for the new design of the rocket that they're flying in, but we have to go ahead and start building those engines because it takes a long time to build
Right.
these incredibly powerful engines. And so one of the things we've been able to do with our restart program is incorporate some of these technologies like advanced manufacturing. And so this morning in the talk, I talked about a particular component, and we're just talking about one small component that helps us regulate the slosh when you move the liquid from the liquid
Yeah.
oxygen and hydrogen tanks into the engines. You got to make sure when you're flying through the atmosphere that you don't have a lot of slosh. And so we have something called a pogo accumulator, and it has a baffle in it. And we've gone from 127 welds on that component down to 4.
Wow.
And so you reduce the amount of time it takes to manufacture, you increase the reliability, and you increase the safety too, because you have so
So you were able
much
to
less.
build that up layer by layer with the additive.
Yes,
Wow.
absolutely.
Okay.
And so our partner Aerojet Rocketdyne has done a phenomenal job of benchmarking and really developing this technology, qualifying it for space. We have a whole test program with those engines where we've tested those individual parts to make sure that they're certified and qualified for flight. But it's been a game changer especially for developing those new engines.
Yeah. Yeah. I love that you described this multi-million-dollar piece of equipment made with the most advanced manufacturing technology. And you say the word slosh, and everybody knows what you're talking about. Literally, you said that, and I'm thinking because I'd done a story with some folks who fabricate tankers,
Uh-huh.
and that's an issue that you got to keep those things on the road. And
Absolutely.
anybody who's ever taken an on ramp a little too fast, the G's are not going to go working in your favor.
That's
as
right.
you do that. So in a way, and this is what I want to ask you. NASA's a big organization, but there are a lot of people contributing at levels that aren't engineers, literally aren't rocket scientists. Because I've had a chance to talk with a person that worked in the sheet metal department over at Cape Kennedy. But there's a lot of people contributing to the success of these programs. Is that correct?
Absolutely. When you think about the rocket, I think one of the most important things I like to talk about is the people that made it happen. There's a tremendous number of components that had to come together. It's a massive rocket. But the most important thing is the people that are making those components that build up to be that huge rocket. So we have in the whole Artemis program, we have over 3,800
Wow.
suppliers that involves about 60,000 people across this country.
Wow.
And so it's really America's rocket. There's just a tremendous capability in this nation that has been brought to bear on that. And we have international partners as well. We're getting some of our components, some of our backup propellant providers from France. And so it's not just America. This is something that the entire world can be proud of and look forward to our future.
You're from Canada. You're international.
Yes, and there will be a Canadian aboard the next.
There will be.
Well, that's kind of exciting.
Absolutely. The Artemis 2 mission, which is scheduled to launch sometime about this time next year in around 2025 in September, will have 4 astronauts on it: Reed Weissman, Victor Glover, Christina Koch, and the Canadian astronaut Jeremy. And so it's going to be really exciting to have this incredibly diverse set of astronauts flying the first human mission back to the moon in 50 years.
Wow. Well, you had the chance to be at the liftoff.
I sure hope I will be.
Yeah.
That's my plan.
So have you been to a liftoff before?
I have.
Okay.
The launch of the first Artemis 1 mission was probably one of the highlights of my career.
Yeah.
I had worked on the program since 2011, since its inception. And so getting able to go visit the vendors and see all the people that had been a part of putting that rocket together, and then being there for the day that it launched. We went through 3 launch attempts. We had 2 hurricanes come through while we were on the launch pad. So
that's not funny. I just like
I'm
from Louisiana. I'm from Louisiana, and I know the prep. I'm like, all right, all you rocket scientists, grab the white bread and get your beer. Let's go.
And we had a lot of hurricanes when we were still under manufacture at the Michoud Assembly Facility in New Orleans.
Oh yeah, no.
So
yeah.
we had some weather impacting us. But we rode it through. The rocket did great. And so when it came time to actually launch that day, and we'd been through this a few times, you try not to get your hopes up because things happen. But we learned a lot of lessons from those attempts and made us better and more ready for the next try. And so when I heard the go for launch we're ready, all the systems are ready, let's go for launch, I ran outside because I wanted to be there and truly experience it. I didn't want to be in a room.
Right.
So I met some of my colleagues out in the parking lot and we watched as it ticked down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1
Yeah.
and lift off. And it was like the sun was coming up on this new era of exploration. The visuals, the sounds, the feeling, you could feel the engines roar, you could feel the vibrations in the on the ground, and to see those solid rocket boosters ignite and just lift off of this incredible rocket was just it was very moving. So
Yeah.
yes, I was there for that one. There's nothing like a light night launch.
Right.
So it's something that'll stay with me forever.
So, I grew up in Louisiana and took an eighth grade field trip to John Stennis space facility, and just remember seeing the huge rockets that would be used for space shuttle launches,
Yes,
and just the
yes,
scale of these things is just it's just
they're
awe-inspiring.
enormous.
What type of facilities are you working in Huntsville to create these rockets? Like, what type of size are we talking about?
Well, the majority of our very large structures are built at the Machute Assembly Facility in New Orleans.
Okay.
So there's a manufacturing facility there that's 43 acres of manufacturing under one roof.
Wow.
And so that's where all of our liquid oxygen, liquid hydrogen tanks, the engine section, the inner tank, all those major structural components are built there. However, in Huntsville, Alabama, we have had the opportunity to build, in partnership with one of our local companies, the launch vehicle to stage adapter. And so that's the cone that the upper stage fits down into, and it
Okay.
provides a connector between the big rocket and the Orion. And then on top of that is something called the Orion spacecraft adapter. And that was an in-house project that our engineers got to do hands-on build in-house
Oh,
at the
wow.
Marshall Space Flight Center. And so projects like that are a great way to inspire the next generation, the younger engineers that are coming along. They get to go through the whole design process, the reviews that you have to go through. They actually get hands-on experience with some of these incredible machines that we do friction stir weld there in Huntsville, Alabama. And so they get to really learn what it's like to run an entire project on kind of a smaller scale, and then they'll be ready to do it at the major program level down the
Wow.
road.
So as a leader, as you're putting together a team, what do you look for in a team to ensure that it's effective and that you're able to kind of create these mission critical components to be able to launch into space?
It's a really good question because you need a lot of things. You need specialists and subject matter experts that really understand all the details of the technical aspects of it. But you also need good leaders and good managers that know how to pull in the right people to make a team. Um, we hear a lot about diversity these days, but you really do need that diversity. You need people that have had different experiences, that have come from different places, that have different backgrounds. And so all of those things go into having a team that thinks about things from many different angles. So we make sure that we've thought about everything. In a project of this size, you can't overestimate how important it is to have that diversity and to bring in leaders that engage everyone and try to make sure that everybody's voice is heard.
And for the supply chain and all of the suppliers that you do have, for those that are maybe interested in getting involved in something like this, what kind of steps can they take in order to kind of be a part of something so amazing?
Sure. So it takes both small and large businesses to build a program of this magnitude. We, as NASA, have several prime contractors that are responsible for the various components of the rocket, like the stage, the engines, the solid rocket boosters, and all those adapters we talked about. And so they are responsible for the individual connection with the suppliers and the sub suppliers that are under them. And so there's a program at NASA where we encourage the use of small businesses. Each of those primes has their own requirement of how they go about engaging those. But NASA runs workshops all the time to help encourage and engage small businesses and teach them how to work with our primes. And so if you go to the NASA website, there's some information on our small business program. NASA does a really good job of engaging small businesses and encouraging them. We've got some really critical small businesses that are providing major components for our program.
And they're not all huge. I mean, some of these, I mean, they're further down the tier, but I mean, they know they're doing this for this project, and I think it's a real, something they can be really proud of, and not everybody gets to contribute to something like this.
This is so true. One of the most exciting things that I've gotten to do is kind of a little bit before we were launching, when we really needed our suppliers to understand how important their role was. We took some of our leadership to some of the suppliers, and we went out and explained to them how important what they're doing is, and how it's going to impact the future of this country and our ability to send humans back to the moon. And the people that are there manufacturing and working on those parts every day don't always think about the bigger picture and
Right.
what they're contributing to. And so it was so much fun to go out and talk to these individuals and get their perspective on what it meant to them to be a part of something that's historic in nature, that hopefully will be around for many generations to
Right.
come.
If you're old enough, you realize the impact that those early NASA missions made, and it's worked its way into our lives, and people don't even realize it. So I can imagine what exactly is being done on, for this project that, maybe my kids or their, the next generation might be involved with. I know it's not Tang, but, in terms of like advanced manufacturing processes
Absolutely.
that may be used to manufacture stuff. You mentioned friction welding, and obviously I think there's a certain application for it, but inevitably in our world, our readers, the metal workers, and the fab shops are always being asked to do something that they're not they're not quite sure how to do it, and there's multiple ways probably to attack it, but you know it gets proved out in applications like in NASA and space travel, and you're seeing that firsthand. What's that like to kind of see the future almost?
It's a great experience. I have to pinch myself sometimes to remember that this is all real. It's not just science fiction books anymore. We're really doing this, and this is really the future. This is something that will inspire the next generation, hopefully encourage them to go into STEM professions. I found that as I was growing up and as I was thinking about my career, I wanted to do something that made a difference. And so for me personally, materials, the idea that I could take something new and create a new material or process it a different way and create a new technology that we'd never used before was just really attractive. And so hopefully when people think about the space program, they'll think about all the innovations and things that they can do to help make us successful. I mean, the idea of putting humans on another surface of another celestial body is just,
Right.
to me, it's just, it's kind of in our DNA. This idea of exploring and seeing what's beyond is just something that hopefully will encourage the next generation to want to make a difference.
You feel the same way?
Like, I mean, how can you not? I mean, it's space. It's the next frontier, or
Did
the
you, did
frontier
you
we've
ever dream of becoming an astronaut?
No,
No. Ever dream to become an engineer?
no,
Okay.
no. It wasn't something when I was growing up that it was really promoted, and I think that was kind of a shame. And I think we're seeing more and more, especially you talked in the presentation about your father and that inspiring you, but I don't know that a lot of kids necessarily have someone in their immediate family that can expose them to that um career path. So it's interesting to look at how we can inspire people today in order to bring them into the fold in different unique ways that maybe we hadn't been able to before.
And you kind of mentioned that, right?
Yeah.
Like in terms of, you mentioned encouraging people going to STEM careers. Do you feel that's kind of part, not necessarily, it's not on your job description, but do you feel like that's kind of your role as well?
I do. And while I may not be hiring the next generation that's coming straight out of college, it's really part of my job to make sure that we have the resources and the people coming along behind us to take this over. NASA has some people that have been around for a while, and they're looking to retire in the next 5 years or so. And so we've got to make sure that the next generations learning and ready to take over that. And there's just so many ways that we can engage and inspire and pique kids' curiosity. My guidance counselor in high school said, "Oh, you're somebody that really likes math and science. Have you ever thought about engineering? Well, I had no idea what engineering was at the time. So she sent me to engineering open houses in local colleges. And so that kind of opened my eyes to the possibilities. And I just always try to encourage people to expose their children to lots of different career opportunities because you never know what's going to pique the interest of a child.
Yeah. I, I read this post on social media. I don't even know what the context was, but the person who put it up there said, like, America didn't realize how many things might just come grinding to a halt when a certain 60 or 65-year-old person just retires because they're the only ones that know how to get it done. Like, do you feel like NASA's in a good position in terms of maybe replacing those knowledge experts who've been around and who've worked on multiple missions? Is NASA in a good place for the future?
I think we are. We have a number of really exciting programs where we engage interns at all levels, from high school to college to graduate school. And so they have an opportunity to come spend anywhere from a year to 2 years working side by side with some of those graybeards, as we like to call them,
Our favorite pirate.
and learning what they do and why and how they go about it. And so it's really good for both of us. It helps the people that have been there a while look at things from a different perspective and understand the new technologies that might be out there. And then it helps inspire the next generation to see the kinds of things they can be a part of. And they have an opportunity to really engage and do some of their own research and design, and they get to do presentations at the end to people that are there at NASA. And so it's a great way to encourage them and inspire them and help them see what they can be a part of if they finish that engineering degree and look for the future.
When you were growing up, did you think about space at all?
Did I think about space? I don't think I mean, I was aware. I can remember when we landed on the moon, they brought, and this will amuse your younger generation, they brought a TV into the classroom.
Right.
And I knew something really big was happening because they never brought a TV into the classroom. And so the fact that we got to watch that, we got to watch the moon landing, I think it kind of sparked some curiosity and some interest in all of us. At the time, I didn't know how I could be a part of that.
Right.
I really was pretty young at the time. But but since then it's something that I kind of fell into. But once it gets in your system, it's just it's something I've wanted to be a part of from those very, very first few times I spent in the lab.
Yeah. Do you see the return kind of generating that same type of inspirational moment for young people, you think?
Absolutely. We have a lot of really sharp, really bright engineers coming on, and they want to be a part of it.
Yeah.
It's what we call the Artemis generation. I mean,
Hmm.
it's really the next generation that's going to be taking us and completing all of these incredible plans we have for building an infrastructure and being able to live and work on the moon. And so there's a whole career path out there for anybody that wants to be a part of it.
During the presentation, you talked about working with materials in near gravity or with no gravity. How does that work? Like how do you get into a moment where you're like, let's test these materials and see how they handle it in those situations?
So that was my very first project at
Wow.
NASA, was working on microgravity experiments. And so in materials, when you melt something, if you have an alloy that has two different densities, one tends to float, one tends to sink, just like oil and water, each time there's a difference in density. And so by taking gravity away, you could produce more uniform and more chemically perfect materials, which had less defects. And so it was a way for us to kind of take out the variable of gravity, understand what was really going on. And then from what we learned, we could apply that and make better materials on Earth. So it was a great opportunity to kind of learn about something unique and a tool that we had, this microgravity environment. And so there have been experiments going on the International Space Station for over 24 years now. 24/7, there's a laboratory in space orbiting the Earth in low Earth orbit, and we're learning a lot of really important things about human health, about materials, about just the way the way we can learn better to live and work in space for the future.
Is this all laying the groundwork? You talk about the next generation, and the reason I asked about the science fiction thing is, I mean, inevitably Mars is like, the thing that's in literature, John Carpenter, all this stuff. How how long do you think before humans get there?
We have some things to learn. There's a lot that we need to get really good at before we venture off. The going to the moon is a few days away.
Right.
Going to Mars is months away. So there's things that we need to learn about living and working on the ground in situ on the moon, in situ resource utilization, the ability to take from the regolith that's on the moon and do things like extract metal so that you can do 3D printing and not have to take all your sources with you.
Right.
We can build habitats using the regolith with the binder and do basically massive size 3D printing, almost like squeezing out a from a tube of toothpaste and layering up layers of concrete to build habitats. And so there are a lot of things that we need to learn how to do before we go to another planet because we can't take everything
Right.
with us when we go to Mars.
Yeah.
And so there's a lot of things you can create, you can extract oxygen from the soil, from the regolith. And so there's a lot of things that we're going to learn by living and working on the moon. And it'll probably be a few years. There's some technologies that we need to develop. We need to be able to refuel in space. And so there's some things we're going to really learn to do before we're ready to move on to Mars. But I think it'll be in our lifetimes.
Yeah. But this mission is critical to any such plans in the future.
Absolutely. It's just the beginning of it, where our next major steps are being able to take crew to the moon, return them safely. And then the next mission after that will have the human landing system on it. And so that'll be the one where the crew gets in the module and goes to the surface of the moon. So lot of exciting missions coming up ahead of us.
Wow. Yeah. I think we're getting there. Drop your name when I apply to Starfleet Academy when I'm 79. You got any questions, Garrett?
No, I was just saying, Dan's just looking to start his own fab shop on Mars. He just
There
wants
you
to get his
go.
foot in the door.
It's important to
I
get in
love
early.
it. Yeah, it is.
I need any advantage I can. Being the only person on the planet might help me. But then again, I wouldn't trust myself to actually excel there. So,
Well, Sharon, I know you also ran the fabrication repair program for NASA. What was that time like?
That was the In Situ Resource Utilization and Repair Program. At the time, I was working at headquarters, which gave me great perspective on just kind of the big picture of things. But it was the very beginning, the very early stages of some of those projects where we were looking at extracting metals. We were looking at how we could extract oxygen. We were looking at taking 3D CAD designs. Instead of taking a bunch of parts, you take the feed material, you take a 3D printer, and you take your design plans, and you can build parts to repair something that breaks while you're in space. And there have been a lot of those kind of projects that are actually working on the International Space Station now. And so just that was just kind of the beginning of it. And with technology developing the way that it has, it's an endless opportunity for doing some really neat things on the moon.
yeah, it's amazing how many small things add up to such a large achievement.
Absolutely.
Yeah. Anything else, Gareth?
Really thankful for you taking the time to join us. I know you're on a tight schedule, so really
Yeah.
appreciate the time.
Yeah,
Great-
it's
Great
crazy.
to chat with you.
Yeah,
Good
but I think you
questions.
kind of you I don't want to call it simplifying it, but just you do a good job of describing how all these contributions kind of we're all part of the team almost. Not all of us.
Yeah.
I don't want to take too much
Dan has
credit.
really
You and
done his
I,
part.
especially.
Dan's really trying hard to get to space right now.
But in terms of like everybody contributing and just working on these separate aspects of the project, it leads up to a bigger achievement. And I think, for people of my age, this isn't just a visit. I think that's what I'm slowly learning is that this is for an extended stay and to lay the groundwork for future exploration, whenever that may be.
Absolutely. This is something people may say, oh, well, we've done that before, but we've not done what we're talking about doing before. We're talking about a sustained presence of human beings in a harsh environment. And so we're got a lot to learn. But this is the next step in sending humans beyond places we've never been before.
That's awesome. Well, congratulations.
Thank you.
Lindsay, congratulations.
For just being here. I think one thing that I thought was very interesting was looking at how, like, mentorship and looking for having someone, role models within the industry that maybe reflect people that are not necessarily represented in a lot of situations. And how do you see that helping to bring more people into the fold?
I think it's really important for young people coming along to have an opportunity to meet people and see people that maybe have unique careers that they haven't thought about. When I was in my very early stages of graduate school, I met an astronaut who was doing something very similar to what I had done in my educational career. And she was working with us. She was one of our collaborators on the experiments in microgravity. And the idea that I could see this person who was so well achieved in my viewpoint at that time, an astronaut, kind of gave me something to look forward to think, okay, she started the way I did. What kinds of things can I do to be that successful as well? And so I think anytime um, young kids have an opportunity to go visit, maybe talk to a neighbor, maybe there's somebody in your community that you admire that you think you might be interested in. Don't be afraid to go talk to them and ask them how they got their start and what they've learned and how they can, learn from what the experiences that they had. So mentorship is really important. We're really um, highlighting that at NASA. We have several programs where we're trying to help encourage the next generation to take those next steps and to be leaders in their own discipline and their own organization. So mentorship's really, really important for our future.
Yeah. Well, thanks so much for joining us today.
Absolutely.
Yeah, that
Thanks
was
for
great.
having me.
I usually ask guests where they can go to find out more information, but I guess
NASA's
NASA.gov.
Oh, .gov.
It's
See,
NASA.gov.
there you go. Sending people the wrong way.
And seriously, there's some really good information and resources on there about small businesses, about education, about internships. So it's a great resource.
Yeah.
And you can follow us and keep up with the progress that we're making on going back to the moon.
Yeah.
There you go. There you go. Well, thank you again. Thank you, Lindsay. If you have any questions, comments, complaints, send them to podcast@fmamfg.org, and be sure to rate, review, and subscribe wherever you get your podcasts. Thank you and goodbye.
The Fabricator Podcast is a production of Fabricators and Manufacturers Association, located in Elgin, Illinois. The show is hosted by Dan Davis and the staff of FMA Communications. The podcast is produced by Gareth Slager and recorded and edited by Griffin Hammond and Dana Weicker. Sales support provided by Andy Flando. Additional production support by Elizabeth Gavin, Mike Owens, Billy Culpa, Pat Simon, Brandon Geyer, and me, Sarah Spring. Email us at podcast@fmamfg.org. Thank you for listening.
I love that y'all have so much fun with this.